So welcome to my talk, OpenStack Issues that are not OpenStack issues. Sounds a little bit strange, but I think you will get it in a minute what it is about. But first about me. My name is Sven. I'm working with OpenStack since Essex, so that was around 2012. I'm in the IT industry since more than 17 years now, working for different bigger companies to get OpenStack and other Linux and administrative stuff be done. Currently working with the biggest hosting company in Germany for OpenStack, of course. And I'm not sure if anyone of you listened to my last talk in Boston, which was about selecting OpenStack or a distribution of OpenStack which might suit your needs. This time we're talking about DIY OpenStack, so build your own OpenStack instead of just buying a release from a bigger company, because you probably like the OpenStack approach of being open sourced and do everything yourself. And whoever would like to do that should keep a couple of things in mind. And you will probably hit a couple of issues. And about those issues we will talk in this presentation for the next 30 minutes. And you are free to ask questions at any time, so just raise your hand and ask a question whenever you want, because then we can pick it up immediately. So who of you is running an OpenStack which is not based off any release from a company? 1, 2, 3, 4, 5. It's a couple of them. So we can recheck after the session if I covered everything and if you didn't know anything about it. So if you plan to use your own OpenStack or release your own OpenStack, even if it's only for your own company, you should create or set up your own roadmap. This is interesting and important because this is the way where you try to keep your focus on, because there will be a lot of distractions on the way to your OpenStack deployment. And of course, some of you might have some bosses or other people which are a little bit looking to the money, and they don't want you to waste too much time to get OpenStack running and productive. Usually you have two different approaches they usually pick in companies. I call them Donald versus Scrooge for ones who are familiar with the Disney families. The Donald one is the one who is using whatever he has available, like old hardware lying around in some storage rooms, or you scrap some from your colleagues, like this is what we have, build OpenStack on it and run it. And the other way is the one where money doesn't count so much, so you get new shiny hardware with a lot of performance and nice features and stuff like that to build your OpenStack on, because you would like to replace something which is already running on and you would like to get the best out of it. So this is usually what you get, and this is also old hardware with new hardware. And this both has issues. If you have old hardware, it might be out of service already, so you don't get any replacement hardware if it's crashing or if it's somehow broken. And with new hardware, you have issues like features nobody has yet tested well, or you need firmware which is not released already because too new, nobody uses it, nobody has experience, so you're basically on your own on some stages. This is something which hit us in the last couple of months a couple of times, because we got plenty of new hardware, and basically nothing worked out of the box. So if you get a new hardware and you plug it into the server and you start it and it started crashing, you start to debug. And one of the things was, of course, firmware was not, let's say, stable. It was considered stable by the vendor, but not by anyone who was using it. And then you start getting annoying issues and you start debugging, because first you think it's like, well, it's new hardware, it should not be broken. But as you see, it doesn't work like expected. You probably figure out at some level that it's maybe related to your shiny new hardware and the firmware running on it. So you need updates for that. Same for, let's say, new technologies like SSDs. I mean, it's not that new anymore, but many people haven't yet used it in larger scales, so they are new to it and they know about the nice features they offer and they would like to include them, and then they start getting hands-on on those new features. and then they notice like they probably don't work as promised. So this is something where you can say like the old hardware is good for people which are well known to that hardware. They probably know everything about it and they know how to deal with it. And the new one is more like, yeah, let's see what's going on. Maybe it's kind of rocket science, see what happens and what you can make to explode. The next issue is CPU versus memory, because old boxes tend to have less cores than today's modern CPUs, while most of the server boxes already provide a lot of memory for you. And then you run into issues because if you have, let's say, a very decent hardware, it will offer you about 48 CPU cores, and you can put into, let's say, 512 gigabytes of RAM, maybe more, which is quite nice. But this is probably not the only thing you have to keep in mind, because if you are longer using OpenStack, you might remember there was some things called flavors, which was like the default settings of CPU and memory for virtual machines. And I put in a table which was the default before Newton, if I remember correctly. So after Newton, there was no longer a default. But you can see quite nicely, it's most of the time the double amount of memory in gigabytes than CPUs. So if you have like 8 CPU cores, you will have 16 gigabytes of memory. So if you have a ratio like 1 to 2, you're probably on the safe side. What not everyone is aware about, that OpenStack has a feature or a configuration for overcommitting. So you have more CPU cores available in OpenStack than you physically have, because usually you expect that a customer will not utilize a complete core at 100%. So you can probably share a couple of cores between customers. The default ratios is 1 to 16 for CPUs and 1.5 to 1 for RAM. So if you do the math in the head a little bit, so let's say we have 48 cores, you can multiply it with 16, then you will get 192, if I'm not wrong. Anyone with a calculator, we get told in the school that we never will have one available at any time. Can do the math now. So you have around 200 cores available. Just subtract a little bit of it because you need something for your OS, so maybe 180. So you have 180 CPU cores available for your customers, and then check the math for the RAM. So if you double it up, it would be about 180 is 360 gigabytes of memory. So if you have a server which contains 512 gigabytes of memory, you will run out of CPU cores before you even utilize all your memory. That could be a problem because it will completely destroy your calculations when you get your RAM view from your OpenStack installation. And this is only the default settings. I have seen customers which change the numbers quite a lot. So they put more RAM into instance because they need some more bigger calculations. So that's probably fine. But we also had customers doing exactly the opposite. So they have a lot of CPU cores because they do some calculations and they don't need much RAM. And then you will run out of CPU cores even more before you get your RAM to utilization. And even with this default settings, if you have some customers using only the M1 tiny instances, they will consume all your CPU cores before you even get near like 30% of your RAM usage. So you will have nicely equipped servers with a lot of RAM, which is not in use at all. This is stuff which is more or less going into the, let's say, financial stuff. But you should keep it in mind because if they do some math and you know the numbers, you can correct them and say, like, if we offer this to our customers, we cannot utilize our servers, and it will probably break the business case, which is bad. So next, as already mentioned, is the BIOS, IPMI, and firmware stuff. This is something everyone has ever heard about it, but do you really care? Who does regular updates of BIOSes? 1, 2. 2. That's even much less than who's using OpenStack DIY, but well. So 2 of you do regular updates of BIOSes. I think with other firmware it's quite the same. So we got some systems, they have from the vendor provided MS-DOS disks to update BIOSes, which is much likely to happen in data centers. I can imagine how many people still have floppy drives in the servers. Well, no. But anyways, this is how BIOS updates usually are done, or the vendor imagine you can do it. It's probably not what you want to do it, and that's probably the case why you don't do it at all. And if it works, why change? Why change is easy. We had issues with the BIOS we didn't know. It was just bad performance, which in the end was due to bugs in the BIOS firmware, BIOS itself. And we had a lot of issues with firmware. We had bad controllers, so we had controllers which firmware was not really working. We lost some SSDs right on the use, so they disappeared by seconds, and then they came back, which is probably not what you want for a productive environment. Same for IPMI. If you want cool features, you should be really up to date. Otherwise, you use old Windows computer with Java installed to get access to the serial consoles and stuff, which is also what you probably don't like. So this is all stuff you need to cover, and is usually not mentioned at all. And if you don't have any plans how to do it, it will break your neck at some stages. Because if you do rolling upgrades with your OS, which is nice, you have much more control over the server than when you do, for example, a firmware update on a hard drive controller. Because this is something you probably won't do in a live environment while having customers on it. And that's the next point, disks. So we have the good old spindle disks, which offer plenty of capacity. And we have the much faster SSDs, which also have a couple of cool features available you probably want to use. So there's a decision to make, like would you like using traditional disks or SSDs, or maybe both? For the traditional disks, if you really care about security, you will probably notice that it's quite long time if you want to erase them securely. So if you have a productive environment and want to make sure that after a server was used by a customer, it gets cleaned up a little, a process of 8 hours is probably not what you like. Same for SSDs. They offer security features like secure erase, which is awesome. And it takes like 3 minutes, maybe, depending on the size of the disk, to get a quite good erasure of your disk. But this is a little bit on the costly side. And with the encryption, we also got other issues, because we got a nice hardware vendor which decided that disk encryption, or in this case secure erase, is something you can buy. I mean, you can buy the drives, yes, and usually every hard disk which is available on Amazon or whatever and is an SSD and has security features enabled can use it. But if you buy this specific vendor's SSDs, you can't use it without buying a license for it. And by a license, I mean you have to buy a license for the controller where you attach your SSDs to it, which then allows you to secure erase your SSDs after paying for it, of course. And they say it's because it's faster than on traditional hardware, so it's a benefit. So that's the reason why you have to pay for. Not sure if that's a good idea, but if you play around with that, check if your vendor doesn't rip you off with secure SSD encryption or secure erase for that. Next thing, network. We got shiny new network cards and shiny new switches. We have 25 gigabyte network cards, which is quite huge. And many people would like to have them, but they didn't work at all. So in the first checks we had, we did not get a link at all. Reason was firmware was too old or outdated or broken, so we replaced the firmware. Next thing we had, the kernel version was also not very happy with this NICs. And we got very unreliable connections. So we got a bonding interface, which was only using one of two interfaces after a reboot. And the only solution was to restart networking again after rebooting, which is probably also very bad behavior for a productive environment. And the reason was simply because there's like, let's say, a bug in the kernel and a bug in the kernel module and a bug in the firmware, which together doesn't work. So you can try to fix that, but I bet you won't do that on your own. Same on the switch side, we got shiny new switches. after we bought them, we figured out that some features were not yet ready. We were promised otherwise, but well. After they came available, they were not working like expected. And now we are at a stage where they are basically working, but not as we want. So we still have issues on that side. And that's with shiny new hardware. So it's not something like you scrap off old boxes from eBay and they don't work, which is probably what you expect. No, it's new hardware from a new vendor. And it all distracts you from running your OpenStack, because you can install OpenStack in minutes on a working environment, but if you have a broken environment, it will take ages, because, yeah, you get issues like Open vSwitch is not working correctly because connections drop all the time. And then you figure out it's not like an Open vSwitch or an OpenStack issue, it's a network issue. So this is all stuff we hadn't on our list when we started with it. And in the end, it slowed us down by roughly 3 to 6 months, just for debugging purposes in some directions. The good news is we have OS updates. And that means OpenStack and operating system updates. And both are working quite well today. If you're long-time OpenStack users, you might remember that OpenStack updates were not very easy in like 2013 and 15 maybe, but it got better and better each year. With the OS, it's a little bit different because OS updates are quite there for a long time, and if you choose the right operating system, whatever that might for you, you will probably be very happy with the update process. What you should keep in mind, if you don't have your own mirrors or repositories available, if you reinstall a server after a couple of weeks, it will get completely different software than 3 weeks before. And if you do some tests, that might happen quite often, and then you will get different test results, even if you didn't change anything besides reinstalling the server. So if you plan to do something like that and running your own OpenStack installation, invest into something like a mirror you have under full control by yourself very early, because that probably can save you a lot of headache. The biggest issue we had was with a CI. So the question was, do we want a CI or don't? Who is with don't? Perfect. Who has his own CI running? Not so perfect, because it's exactly 0. And I didn't know why you didn't raise hands, because I know we run our own. So a CI system is quite useful to test your code and your packages and the combination of it when you deploy your own OpenStack. And when we started, we just Googled around and found OpenStack infrastructure has a lot of information about it. And we thought like, wow, cool. We just copy over the OpenStack CI to our own systems and voila, we have a CI. And then we imagined they have like a ton of servers and we don't. So we tried to scale it down, which didn't work. Then we found another page which was stating like a minimal CI. There was a small note, this page is probably a little bit outdated, was like 6 months old or something like that. And we found out it was not only a little bit outdated, it didn't work at all. So the whole code was not useful. It was generally okay to at least learn from it, but just running it on your servers didn't bring you any benefit. That took us like 3 weeks to figure out that this is seriously broken. So what you still can do is you can scrap out like tests and other informations from existing environments to do your own CI, because a CI system is rather complex and tests are key. So if you have good tests, you can avoid a lot of issues over the time, because they are hopefully covered by all your tests. And if you scrap them from anyone else, you don't have to rethink all the stuff by yourself, which is quite good. And if you take a look at what OpenStack infrastructure team did with the whole CI system, it's amazing. They have tons of tests for everything. Probably you don't want, because if you check in some code, it took like half a day on your own system to get everything checked, which is not what you probably want if your developers are waiting for feedback, like, is this code okay? It's like checking in the morning, and when you get home, you can see if it was okay or not, and the rest of the day, you probably just wait. So don't overdo it at first. Try to keep it small, and make your own way, but don't forget about the CI, because this is what we did in the early beginning, we just developed and developed and developed, and then we noticed it didn't work, but we didn't know when it stopped working. So probably worth an invest. Other issues we had is kernel issues. So you run your OpenStack on any Linux, you will have some kernel on it, and it will have bugs. Bugs I run across in the last years was there's a Intel NIC which didn't work when you put a bridge on it. So, well, it works, but it's slow. Then there was the mentioned Mellanox cards which have issues with the current deployed kernel by the vendors, so you have to update it by your own. You have some of those very annoying issues with newer CPUs. You have some issues with memory sometimes, because some of the servers provide very shiny new memory features for mapping bad blocks and stuff, and they usually don't work like you expect if you don't tune them. Same goes for tuning at all. So if you don't tune your kernel for high-speed NICs and throughput, you will probably not get the speed you paid for in first place for your whole network equipment. OpenStack is also very good in digging out issues in software. If you have ever installed OpenStack, you will probably notice that OpenStack is basically just a bunch of Python scripts around already existing software, like HAProxy, MySQL, Apache, different types. And since it's very easy to utilize a big platform with OpenStack to a level where you normally wouldn't come through in like a year if you just do normal deployments on it, you will find software issues or bugs. And sometimes it took some time to get them fixed upstream because, yeah, it's something not everyone can really like reproduce. Like you mentioned that if you set up a 500 servers cluster, it breaks. Then they say, okay, we have 5 servers. What do you expect us to do? Buying 495 more servers to test it? So this is something which sometimes also consumes a lot of time, and OpenStack issues or issues OpenStack digs out in existing software in libvirt, for example, also sometimes need some time to get fixed upstream because they could break other stuff when they fix it. And since libvirt is quite widespread used, this is something you would take serious. So it's not like, oh, there's a bug fix for it, which is only one line, I just apply it and then it's done. Could be done that way, but they want to make sure that it's not breaking everything. But we have seen otherwise. We had a bug which was fixed in less than 2 days, I think. If you remember, the MTU issue was 2 days, I think. Yeah. So, and that's something you can only fix by yourself when you have full control over your packages and stuff. So if you rely on something like a vendor, it's much harder to replace software in such environments like when you do it on your own. The next thing we used was the famous Puppet modules, which the OpenStack Foundation provided, and the OpenStack project, of course. And they are surprisingly good. Well, it's not so surprisingly, but they are really good. So when you use them, you get very stable code and very reliable product. What you don't get from other Puppet modules, you probably integrate in your environment for other stuff you need. So we had a lot of issues with the order of when modules are executed and tasks are done, which we discovered that they were related to a feature called anchors in Puppet, which is officially not let's say, state of the art anymore. It's deprecated, I think. And they work, but only the OpenStack modules make use of it and others don't. So in combination with other modules, you can break your whole Puppet deployment. Fixing that is possible, but it's something you need to do yourself sometimes because it's something you only see in larger environments. So like if you deploy a module on your own for one server, you probably will never get into that issues. Or if you get into that issue, you fix it maybe otherwise. But if you integrate OpenStack modules, you wouldn't change OpenStack modules which are known to work good just for that reason. So you need to change the other ones. And there are plenty of modules you probably want to use or change. And the best thing you have to dig out problems are customers. Customers are always problems. Customers, sorry. The customers usually come to your OpenStack and have in mind like something they know already, like a virtualization platform, and they know how it works, or they think they know how it works well. So they come to your OpenStack, deploy, and then they start questioning things. Like, why do I need to do it that way? I was used to do it that way and it worked. You can start changing OpenStack the way they want it to be, but you probably will break other things you don't want to break. Sometimes those customers are good because they find issues that are really issues. And one of them is the OpenStack CLI is a little bit slow. And with a little bit, I'm talking about seconds. So if you enter a command on the command line, which the OpenStack CLI doesn't know, it took up to 2 seconds to get a command not found back. And those 2 seconds also come into count by every command you issue against the OpenStack CLI. And then they start questioning, why is OpenStack so slow? Then you test your OpenStack and you see it's not. And then you get told they use the CLI. And then you use the CLI and see the CLI is slow, but OpenStack isn't. There is a couple of things ongoing on this issue because it's getting bigger and bigger with each release because more modules get included all the time, and that slows the process down even more. There was a suggestion where you can run a preloaded OpenStack CLI daemon, which preloads every library, and then you can just ask it over a socket, and then you get a lot faster responses. It's up to 2 times the speed you get normally. So if you have customers using the CLI and they mention OpenStack is slow, check if it's not the CLI itself, or let's say the module collection of Python libs and stuff, which is the real problem here, and your OpenStack is running fine, but they don't know because they never see it running fine. Another issue, if you have customers which deal with SSL traffic, they will probably mention that your VMs are slow in SSL traffic. Many people think like, yeah, it's a VM, it's slow every time, so why should I waste time on investigating into that? But there is real problems on it because OpenStack is quite good in trying to get the best out of your setup, and some CPU features get masked out. So if you have a non-heterogeneous network, it's no problem because you can spread like live migration all your VMs over the cluster. But if you have some CPU features which are only available on a couple of servers, you probably want to mask them out so that you can migrate over. Doing that also can mask out features like hardware encryption of the CPUs and stuff, and then you get really slow VMs. And they are only slow in some use cases and not in every use case. So it's hard to debug why the customer is complaining about slow VMs on one side and the other customer is quite happy with the VMs. So take care about that because this is configurable in OpenStack and many people just ignore it. And then a thing which we run also into, read the docs. Sometimes docs are quite good, and OpenStack documentation is one of the best I know from projects. Issue here was quite easily. We started to deploy our services, and we found out like, oh wow, you can integrate OpenStack APIs in Apache using WSGI, works perfect, awesome. You don't have to use the Python stuff for that, which is maybe not so reliable like Apache is, and you have many people with good knowledge about Apaches. So why not putting everything in Apache? And we ended up in doing everything in Apache, including the Nova API, which is something you would probably put at first in Apache. But it raised an issue because if you read the docs carefully, it states that's not yet supported. It works, but it's not supported. And the reason why it is not supported is because it doesn't create a correct services entry in the database for the OpenStack services, which led to the problem that if you start a VM after a new deployment, the service entry is missing, and every time you start a VM, you get an error that it could not start a VM, but after 1 second, you refresh the page and the VM is there. The reason was missing version in the database means that there was fallback code used for older releases of OpenStack, and that doesn't work with the current release. So you get like a race condition. Took us some time to debug and to find out. It was not very good, but well, yeah. So if you deploy something and you start like, oh, this looks good, just check back the docs again if it's really supposed to work like that. So we're having like a couple of more minutes, so 5 more minutes. So I have a small extra about Ceph. I mean, who's using Ceph in his OpenStack deployments? That's plenty. That's good. So, of course, we did Ceph in our environment too. And as said, we have shiny new hardware. So we have all-flash SSDs in our Ceph cluster. And we expected huge numbers of performance. What would you otherwise do if you have SSDs? But we didn't reach those limits we had in mind. A SSD is easily capable of around 20 to 30,000 IOPS without problems. We have some which are even rated with 40K IOPS. So if you put like 200 disks in your Ceph cluster, you would probably expect big numbers. The number we got was about 1 million in the cluster in total. So for the customer, it's about 300,000 IOPS available. Sounds pretty neat, but compared to 200 SSDs you put in your cluster, 300,000 IOPS is not what you expect. And there was an easy reason for that. And that's simply, Ceph is usually designed for traditional hard drives, the one who turn around, not SSDs. And they are having a capable limit about 500 IOPS per gigahertz you put in your Ceph cluster. So just keep that in mind if you do Ceph. 500 IOPS per gigahertz is available, and that's the limit Ceph currently offers. There's progress of raising that limit. But if you do the math, like how many cores and how many gigahertz you put in your Ceph cluster, multiply that with 500 for each gigahertz, you will get a number which is probably your limit if you use only SSDs or a combination of it. You won't ever get beyond. And that also can break your use cases or your business cases because, like I said, we put 200 SSDs in the cluster and the cluster is not as fast as we expect. We can split it up, then we probably get a little bit more. So if we put more CPU cores into it, but running those disks in the big cluster didn't give us the performance we wanted, which is quite sad because Ceph is a good product. So yeah, that's it for the presentation, and I haven't seen any questions so far, but now you have still time to ask questions. No questions? You won't get shot? Ah, there's one question, yeah?
You mentioned about Puppet modules.
Yep.
Is that what you're using to build your OpenStack components with? Or did you explore, like, do you have an opinion on the state of those modules versus other, maybe, because this seems to be a plethora of alternatives.
So the question was, just because it's not recorded properly, if the Puppet modules are our state-of-the-art requirement, or if we tested other deployment methods, and why we choose those Puppet modules over probably other, maybe better solutions. There was indeed some time where we tried to figure out what would be the best solution to deploy OpenStack. We came to the conclusion that Puppet modules are well tested, still in use by the OpenStack Foundation, by all the official deployments, and they are also including tests for itself. So if you change something on a module, it includes some tests you want to run probably to make sure that the module works fine. The whole combination of that was the reason why we picked those modules. I would say it's probably not the perfect solution on the planet, so there might be better options or different options. As stated, in combination with other non-OpenStack Foundation managed modules, you probably run into issues. And if you don't have any, let's say, big experience with Puppet modules, it takes you some time to figure out how they work, how you can extend, how you configure stuff, and so on and so forth. So I think it's a robust, good start, and you can rely on them because they are still heavily deployed. But if you would ask me as of today, I would probably take other paths to deploy OpenStack. Any other questions? Last chance? Nope. Oh, yep.
At what point do you bug within, say, within OpenStack and the version you're using?
So the question was, at what point we decided it's an OpenStack bug or a kernel, hardware, software, whatever bug. That's the reason why I did this talk, because in the first it's like you roll out OpenStack, something doesn't work, you give OpenStack fault because it did work before with other deployments, other setup. You probably run other software on the servers before that run fine and OpenStack doesn't, so it's probably OpenStack fault. It's really hard to differentiate between those bug types. At first, that's what most of the people do, I think, is you blame OpenStack for that. And you probably find a lot of bugs on Launchpad and the OpenStack side telling you there is something wrong with OpenStack because it didn't work and stuff like that. And in the end, it wasn't really OpenStack's fault. And the reason, or the way to differentiate what is really the problem is really to dig into it, which is quite hard at some levels. It took a couple of days to dig into kernel bugs, for example, because it's not something you do on a daily basis normally. And if you just install software and it didn't work, you blame the software first. That's completely normal. But at some levels, you will see that, for example, what is a good indicator is like if I change the software and the bug consists or the problem consists, then it's probably not only a software issue or it's not with the particular type of software. As said, there was a bug in a combination of Intel drivers and bridges. That could be found on any combination of bridges and Intel NICs, but only OpenStack by default uses tons of bridges and will raise this error quite easily, while if you deploy a server on your own, you will probably not set up a bridge at all. So it's not easy to get into those bugs and say this is like an OpenStack issue or not. What is a good indicator if OpenStack complains itself, then it's probably more OpenStack related instead of something else. If there is no complaint from OpenStack side, then it's a good pointer to dig deeper into the issue than just blaming OpenStack for the issue itself. That okay? Okay. Last question? Someone? Nope? Perfect. So I thank you for being my attendees today, and a special thanks to the OpenStack Travel Support Program, which is the reason why I'm here today. They supported me this time. So if you encounter any issues, don't forget how great OpenStack Foundation is to us, offering us such nice programs and this awesome event. Thank you.